Hi there. Today we're going to talk about interval notation. And interval notation is just a way to express a range of numbers from one endpoint to another endpoint. We can include those endpoints, or we can just say everything up to those endpoints. So let's go back to experience that you had perhaps in elementary school. When you were graphing everything greater than a number or less than a number, maybe greater than or equal to a number. So we're going to start with just greater than a number. Let's say that we were wanting to express everything that was greater than the number 2. Do you remember back in the day, you would put a circle over the 2 and shade everything to the right of 2, and then you'd arrow it out. Okay, so this is what's referred to as an open interval, something that has everything bigger than 2 but not 2 itself. So we're going to show how to use that in just a number notation and as well on the number line. If we are going to do a little bit more sophisticated math, we're going to use this open parenthesis on the end of the number line, and this is the same as using an open circle. It just indicates every number to the right of 2, but not 2 itself. And if we were talking about that in terms of how do I express that, you used to say x is greater than 2. Okay? But if we use interval notation, we need kind of a left end and a right end. So let's think about the left end here is 2. And we're going all the way, there is no right end. So we talk about going towards infinity. From 2 to infinity is how we read this interval. And the parentheses imply an open interval. We're not including 2, nor are we including infinity. We can't. It's not a location itself. And so the parentheses just indicate we're talking about something that we can't actually include in this range of numbers. So when we talk about a closed interval, that would be when we express something like x is less than or equal to 1. So let's go ahead and show how we used to do that on the number line. Remember, we would put a closed circle, hence closed interval, and we would shade everything to the left of that circle on the number line. The only change here is a little bit of a notational change. Instead of that closed circle, we're going to use a square bracket instead. And it does the exact same thing as that closed circle. So instead of this notation, we're going to use interval notation. And again, we start from the left and go to the right. Well, where's the left end here? Oh, there isn't one, but it's going towards negative infinity. Okay, and it ends on the right at 1. Okay, just like on the graph, we put a square bracket on the 1. And we're going to always stick with a parenthesis around infinity because we can't actually get there. All right, how about this example? What if we said 5, 6, 7? What if we said we were interested in this set of numbers? Okay. And this is saying from 5 to 7 inclusive, okay? We would write this in set builder notation like this. X is greater than or equal to 5, but also less than or equal to 7. And in interval notation, it's really easy. You just say the interval between 5 and 7 and use the square brackets to say we're including those endpoints. Okay, so use what when describing infinity, either positive or negative infinity? We're always using parentheses. parentheses or open intervals. So next we're going to talk about conversions between what's considered a set builder notation and an interval notation. And here we have some set operations, intersection of a couple of sets and union of a couple of sets. So we're going to look at these examples. Let's say I'm interested in x is greater than 17. Well, it's kind of like what we did up there. The greater than does not have the equal sign under it, so it will be an open interval. So it's going to be everything from 17 to the right. In other words, kind of like this. But it does not include the 17. And so this interval would be expressed left end to right end, 17 to infinity, okay, with parentheses around both of them. X is less than or equal to -3. So if I put a -3 on the number line, I'm going to be going this direction from -3. Okay, and I am including it because it's got an equal sign here. So now we're going to move all the way down to the left, arrow that out. And if I write this in in interval notation, we're going from the left to the right. Well, what's the left over here? That's going to be -infinity. To the right over here is -3. And that would be our interval notation. X is greater than 1 and it is less than or equal to 100. Okay, so I need a couple of things on my number line here. I need a 1 and a 100. Okay. It's greater than 1, but it does not equal 1, so I'm going to use a parenthesis on the 1. It's less than or equal to 100, so I'm going to use a bracket on the 100. I'm going to shade everything in between. And then my interval notation is going to be from 1 to 100. Okay, now here's where it gets a little bit interesting, and it's a little more fun, I think, because there's a little more challenge to it. We're going to look at the intersection of these two sets. Now this is a set of numbers between -1 and 3. This is a set of numbers between 2 and 5, and we're looking for the intersection. And remember, an intersection is that set of numbers that both sets have in common. They've got to both share that set of numbers. So let's look at -1 to 3 on the number line. If I look at that on the number line, it would kind of look like from -1 to 3 over here. And do you see there's brackets on both sides? So I'm going to bracket here, shade everything in between. And I also need to look at this set from 2 to 5. So let's look at that on the number line. Of course, 2 is going to be just to the left of 3, and 5 is going to be over here. Now this set of numbers looks different, okay? So it's from 2 to 5, so I'm going to just put it right above here, 2 to 5, and notice I'm going to use parentheses here. Okay, so here's my first set of numbers, here's my second set of numbers, I'm looking for the intersection. Where do those graphs overlap? Where do they intersect? You could consider, right? And that would be from here to here, right? Here's where they both exist. To the right of this, only one of them. To the left of this, only one of them. But right in between here, we have shared numbers. So this would be our intersection. And we would write that as, here's my left endpoint, here's my right endpoint. So from 2 to 3 inclusive. All right, the last one, we're going to consider union. So we're going to go from -1 to 9. And -10 to 1. Okay, now union is a little bit different. Union refers to everything that is represented in either set. So think of them as two different parties, and you want to talk about everybody who went to a party. One party, not both, but one party. And so that would be everything in this group of numbers. So from here on the left to here on the right. And we would just write that from -10 to 9, and both of these would be in parentheses. Okay, so here is a nice little introduction to interval notation. We are going to be using interval notation to express many answers from here forward. So it's a really good idea to get comfortable with this notation and be able to go back and forth between set builder and interval. I'll see you next time, and we'll talk about something really cool.